Hi, it's Gadget UK here again. This time we're back with C64 repair. There'll be a number of these coming up. So you can see it's assembly 250407. It's the one where the clock gen stuff is exploded out here. I showed this board actually on the recent video, the Haybert clock chip. It's like a replacement, you know, the chip that these four chips are consolidated into. Those chips can fail and you can get a modern replacement from Jeff Haybert. So the amazing thing about this is it's got my first 6581 R4 AR. So hopefully that works. It's got a green dot, which may suggest that works. Does this suggest that doesn't? I don't know. I think we'll remove that, I think. I wouldn't want to power it on with that, just in case that does work. And of course, when you're handling these boards, wear any SD wrist straps, certainly when you're dealing with the VIC and the SID and the PLA. And the CIAs, you just have to look at them funny and they fail. Seriously, it's not worth taking the risk. It's got a Rev 3 6569 here. So, you know, this is the breadboard version, funnily enough, in the C64C case. In any case, and it's not got a top, I don't think. Although that may be across the other side of the room, I don't know, I'm going to have a look in a minute for that. So yeah, I think we'll start by just getting out that SID. Now these systems will boot without a SID. It's certainly a good idea to remove it before you check the voltages and stuff. Sometimes you'll find that these burn up. What I mean is you turn it on and then the SID just gets really hot. And obviously that's an indication there is a problem with the SID. I can't get that side out at all. This is where an extractor would make my life easier. There we go. It was sort of out on one side, so we got a slightly bent pin there, but yeah, wrist strap is on. Yeah, that pin's a little bit bent there as well, but it's bent inwards as if it's been bent in the past. So let's just put it on here with that SID. We've now got two of those on there. And we'll power it up, measure voltages, we'll have a feel around just to see if anything's getting warm. It will boot without SID, it will boot without CIAs as well actually, but you get like, I think you'll just get, with one of them you'll get no cursor, and I think the other one you'll just get like a blue screen with no text or something. I think it's been a while since I looked at these. I've covered that sort of thing on lots of other videos that I've done the C64s, although some of them, you know, in the distant past and a bit crusty. So one of the misconceptions with these is people measure the 5 volt down here and go, oh, the 5 volt's alright, you know, so we've done the voltage checks, and then maybe they check the 12 as well, and then end there. Well, actually, you've got 3 supplies. Actually, you've got AC that comes in and gets changed to DC by that bridge there, yeah, rectifier, and they get 12 volts for, I think the VIC uses it, I'm not sure, but certainly the SID. Yeah, we'll check that in a minute. So that's what the 12 volts for, but then the 5 volts here is not the 5 volts for the whole board, it's just the 5 volts for this can. That was something that I learnt from Bawak in Norway years and years and years ago. I didn't realise that back in the day when I used to work on these. So yeah, and then you've also got 5 volts that comes through, not through the fuse I don't think. You also have 5 volts that comes direct from the power supply, as well as that 5 volts, yeah, but that 5 volts comes and powers the remaining chips, including the SID. So yeah, the 5 volts down here is just for the VIC. I'm adding this bit at the end. This fuse here is a good example of where you can get a black screen and you can spend ages trying to understand what's going on. If you've not checked your voltages and noticed that fuse is blown, what you didn't realise is you haven't got the 5 and the 12 volts that are generated on the board itself, regulated down from the AC that comes through this bridge, because that's what that does. I'll show you on the schematics. This is where the AC comes in through here. There's the fuse, F1, yeah, and you can see it goes into the one of the AC side of the bridge rectifier there. That wavy line on the bridge rectifier is AC. So yeah, you got the 1 amp fuse on the AC coming in, and then obviously the output of the bridge here, the positive side, goes to your 5 volts for the VIC can, and then interestingly enough, the AC, the other side of the AC comes through here this way for the 12 volts, because you have an unregulated 9 and you have plus 12. So actually there's another voltage you really should check, I think. Unregulated 9, I think that goes to the user port on the back. Got another faulty board here, that's the user port there. So I'm connecting up my homemade AV cable here, really easy to do. It's just a 5-pin DIN, and you can just have a couple of RCA phonos, one for sound, one for video. Using a normal wedge power supply here, but I've got Bawak's 5 volt saver in line here, and that just cuts the power if it goes more than 5.3 volts, I think, which just protects against those power supplies failing. And if we switch it on, let's see what that does. black screen, I think. Yep, just a black screen. So whilst it's powered there, just have a bit of a feel around here. Yeah, nothing getting red hot so far. Wrist strap is here, by the way. I'm holding it like that. Yeah, so no immediate problems with temperature. Same over here, pretty cold actually. So let's get the meter onto it. So I'll switch it back on again. I'm just going to put the... I've got a red screen here, let me show you. That's interesting. That's making me think PLA faults actually. Could be a RAM problem, but strange how we just got a pink screen. Anyway, let's focus on the job in hand. So I'll measure the voltages here. So yeah, for the ground, I'm just going to stick it somewhere. I'll stick it on the shield up here. We should get relatively good ground, I think. And the positive, let's just check this one over here. The right hand side is going to be 12 volts. Yes, we've got 11.99, and this is annoying, this thing in the way down here, but I can just squeeze the probe down there without shorting anything. Got to be careful because that's grounded onto the right hand pin. We should have 5 volts for the VIC, yep, 5.02. So those voltages are okay. So again, ground down here, let's just check one of the top upmost pins on one of these 7.4 series. 5 volts, 5 volts. 5 volts. So yeah, we've got all the voltages okay. Right, so you know what, the next thing I'm going to do, that's got a red dot on it. The behaviour we're seeing here, certainly on breadboards where you've got the smaller dip, you know, is it 28 pin there, PLA, it's not uncommon for the PLA to be the issue. So you know what, let's just get the wrist strap on, because that PLA may be alright, but let's just get it off and we'll get a replacement on. It's going to be quite hard, I can't get any leverage there actually. I could try and use this extractor. It really isn't the best, but it may just help us with this, maybe. Yeah, there we go, it's coming out easy, look. So let's put that onto the ESD sponge there, and we'll get a replacement in. Now I've got a few of these actually, including one to build, I think. So yeah, you can get these modern, you'll have seen these on other people's channels. I think Jan Beta may have shown these, maybe Adrian Black. You've got some gals on there. So we've got that one, and we've got this one. This one came from Plan C. C64, 25 nanoseconds gal PLA, have a nice day, I think it says. So let's try that one, I think. As I say, I think this one came from Plan C. There'll be a link to his channel down below. Now, one thing I'm aware of here, round pins into socket like that, you know, dual web socket, you widen them, and then if we put the original PLA back in, it's going to make a loose fit. So I have a socket here that has had turn pins in it in the past. I use this for testing things with the turn pins when I want to stick them into a dual wipe socket like that. So we'll stick it into that. So pin 1 is at the top, there's the pin 1 marking. Try and line that up. There we go, it went in pretty easy because it's had, as I say, turn pins in it previously. And let's switch that on and see what happens. Woohoo! So we've made some progress. There's obviously 2 faults with this. Out of memory error, so we've now got a RAM fault. And I see the problem straight away. And in case you're wondering what I mean, MT. Manufacture here, this RAM, MT. Ooh, that one's NEC, that one's NEC, that one's NEC, MT. So it's weird, isn't it, how we've got different manufacturers, but I've seen that before on Commodore boards, where for some reason they just suddenly change halfway through, you know. So I think the next thing to do is get the dead test card onto this. There's a PLA mode that the cartridge switches, yeah, which disables the kernel on here. So it just boots straight from the cartridge. So provided you've not got a data bus problem, and provided the backbone of your system is okay, you know, i.e. the PLA can be used to disable the kernel, and the other address mapping that it provides is working okay with respect to other things in the system, then it should boot, and what it'll do is the first thing it'll do is test the RAM, and it'll flash a number of times to indicate which chip is faulty. Now, if you've seen other Commodore 64 repair videos I've done and other people's channels as well, you'll know that these are a pain in the bum with the RAM as well. So sometimes you can get a RAM fault like that, and it can be one of these. I forgot what these are now, 257s. They might be muxers or something, I can't quite remember off the top of my head. These are often, though, what causes the RAM issue. And, you know, you can find that the RAM's alright and it's one of these, but the MT here is making me think it's probably going to be one of these. Now, the next thing I may do, actually, is just piggyback. We'll do a RAM test first, see which chip it's pointing out, and then I can piggyback and see if that makes a difference. There's a little bit of dirt or corrosion or something down here, can you see this? Is it just fluff? It's just fluff, look. So it certainly needs a clean up. So I've got a dead test cartridge here. There's loads of these on eBay. I quite like the seller of this, though. If I can see the seller online still on eBay, I'll stick a link down below. But so yeah, you get them in a nice shell. I mean, the board wobbles a little bit there, but it's really nice having something that looks like the original ones did. Because you used to be able to buy these from Commodore. Right, switch it on. So I think we're just getting one flash there, are we, by the looks of things? It looks that way. It's like black, white, black, white. The period is the same, so I think that's just indicating a 1, perhaps. So, wrist strap on. This perhaps isn't the best container to store these in, actually, because, you know, plastic, ESD. Anyway, let's just get some of these out. Those are CIAs and things, I think. Right, so straight away, I can see, I think these should do the job, actually. 4264. Surprisingly, these are MT RAM. I think those probably came from Williams' machine. It is Atari. I'll stick a link up there. It was an Atari 800. So let's test one of those there. So I'm going to try U9 just because it's the lowest number. You've got to make sure the pins are bent in to do this. Wrist strap on at all times, and you've got to make sure it makes a really snug fit on all the pins. If you had a loose ground or something, you could kill the actual chip you're using to test here, not the one below it. And likewise, it won't work. You won't get a valid test if you test with a pin missing, you know, a pin not joined. And you can see we've got the same issue. So I'll just simply pull that off and work my way around the chips here. I'll just do them one at a time, and we'll just see if we get any difference in behaviour. You know what, I was changing my approach here. Let's just take that out. One thing that just crossed my mind, this PLA had something written on the top, didn't it, about the speed. It's used a certain speed of chip. This PLA provides the CASRAM pin, I think. This chip has an effect on the CAS signal. It's you know, tightly coupled into the memory stuff. So, like, if there's a problem with the PLA there on that pin, I think it's the CASRAM pin, isn't it? Then something like that might not work. An EEPROM is the same sort of thing. Now, here's another one I got. I got this one off eBay, I think. Let's try this one, because this could just make it work. Maybe it's just a bad PLA. And I think that's the important point, really, is that you could spend ages thinking there's a memory fault with this when actually there isn't. Let's just try that. No, we got the same problem, so at least that's ruled that out. So it does seem to be memory. Now, piggybacking is yielding no changes in behaviour whatsoever, but there is a chance I'm just not getting a good connection there. So I think the next thing I would do is get the logic probe and the scope onto this, actually, just to rule these out here. But also just scope the data bus there. We can see if we can see any clues as to which data bit might be the issue. Alright, we've got the diagnostics from the cartridge there, but you know what, I've not looked that up yet. And one flash, well, it's going to be the first bit, isn't it? Whichever bit that is on here. But I am not seeing any change at all this way. And the piggybacking will only work if, say for instance, it's just not storing anything, it's not doing anything at all, or the bit's stuck low maybe, then it will try and pull it high, and you may just see a change in behaviour. Doesn't always work. So I want to connect the logic probe up next. So I'm going to put the meter on continuity test. I just want to find a couple of good places to clip the probes. I can stick the ground on there to around here. Just see if I can find one of these where I can clip the logic probe onto. Somewhere we've got a dead short to 5 volts, but struggling to find it actually at the moment. Yeah, there's 5 volts. So I can stick the positive on the left hand side of that ferrite bead there. Obviously pay attention to what's around to make sure there's no way it could easily short onto anything. And we'll stick the ground onto the can here, because that's definitely grounded. And as I say, if you're moving it around, just be careful, mindful that you don't short anything. So let's switch it on, and let's just test logic probe here. So you can see it's green, that shows it's indicating low. And let's just have a look around here. So we've got the 5 volts on each of those there. We'll go across here. So we've got pulsing, 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 pulsing. So that's an easy one to check, isn't it? We can just go across here and just check that one. Pulsing, 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 pulsing. So certainly from the logic probe's perspective, the right hand side of those are behaving the same on both chips, which is kind of what you'd expect. So let's just see if we can see what's going on with this one now. Pulsing, 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 pulsing. That should be ground. Yeah. So pulsing all the way along and then ground. So let's have a look at this one. Pulsing, 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 ground. So I mean, on first inspections with the logic probe, I would assume those aren't going to be the issue. But what you don't see with the logic probe is if you're on a scope where it's going high low, it might not be going quite as low as it should. It might not be going quite as high as it should. That's the sort of thing that a logic probe will mask. You will not get that kind of feedback. You sometimes can, and I have done lots of times with this one. So what actually happens is you may see the red is maybe twice as bright as the green. Yeah, but that could indicate that it's the frequency of the signal. In other words, maybe it is high more than it is low, but they are actually pulsing. But with something like that, with these chips in particular, on these, I have seen this where it's like the red can be really dim and it's mostly green on one pin, and you're like, that's probably the issue, and then you swap the chip and usually it fixes it. So anyway, you really need to scope those things, but I'm now going to rule those out at that stage. We can scope later if we don't get any further. I think what I'm going to do is just look at the information for the dead test, work out which chip it's supposed to be here, and just remove that chip and replace it, because I think that's probably going to be the issue. So look at the table for the flashes. It's in U12, which I think it goes 9, 10, 11, 12. It's going to be this one here, and it's bit 7. It's the uppermost bit, not the lowermost bit. Right, so just get a bit of leverage under there. You can see that's coming up. Hopefully I've not lost any pads there. Why is it sticking here? There we go. So, look how short the pins are on that. That's what made that particularly hard to get off. So just clean with the cotton bud and some IPA. And just get a socket. Just occasionally you may find there's a little bit of solder there. Sometimes I'll just poke the hole a little bit here. There's that one there. There we go. It's like the smallest amount of solder. Yeah, so always make sure when you've pushed it in, there's been a bit of resistance, make sure the edges of the socket are not coming out, but you can see that's in, it's flat and flush, just need to solder it on. Wrist strap on again. Got that chip that came off Williams board here. 6264, it's MT again, it's -15, these are -20s, but just plug that in, I'll switch it on, Ah, there we go. That was it. It was that RAM. So there you go. That was an example of how the piggyback doesn't always work. It doesn't give you any clues at all. And I tried that chip several times over the top of the original one. It didn't make a difference. So we'll switch that off, get the diag cart back in, and then hopefully it'll do more tests there. It's going to fail on the loopback test because I don't have the cables connected. What do I mean by that? We can get cables that connect to here I think, and here perhaps, and the joystick ports, and the keyboard connector, wherever that is on here. And it'll like output a signal and then input, etc. into, you know, so that you can actually test that all the inputs and all the outputs and all the ports are working. So without that loopback harness, you get CAAs coming up as faulty. The pot X and pot Y on the SID will come back as faulty. But anyway, we haven't even got a SID at the moment. Let's just, in fact, we can get the SID in it now, can't we? Strap on again. We know the voltages are okay. So let's go with the one that was already on here, the R4AR. If this works, I'm probably going to keep this chip because it's quite a rare revision. Well, it's to me. It's the first one I've seen since I was in the trade. I haven't seen one of these in 30 years or so. And I'm just triple checking that SID to make sure its pin 1 is right, and it is. There's no bent pins, so I really don't want to destroy it. I'll switch it on. And let's see what the dead test card does now. Now you get an extended black screen like this for the, there you go, for the first 10 seconds or so. But I think we can call this one a success. So it was a dead PLA and a bad RAM chip, by the looks of things. Obviously, the proof is in the pudding until we test a lot of games and things and some demos. We're not going to know 100%. I'd like to be able to test some games off the SD card there to see if we can work out if there's any issues with the SID, if the filters are on it, etc. But yeah, very, very, very pleased. That was quite straightforward. All in all, it's taken about 10 minutes to fix that one. So as you can see, and here, it's working. Fantastic. That SID sounds really good as well. I need to do more testing because I'm not sure this makes particular good use of all the features and filters and things. But yeah, very pleased. So whenever I get two faults like this, I'm always wondering what's happened actually. Now it could be a case of this board, the original failure was just one bad RAM chip, and then, you know, it's got sold on, put in storage or whatever, because it had a fault. Now the PLAs, the original one that was on here, where's that gone? Here. These deteriorate with age actually. I think there's a fairly well documented process where the materials they made these from, they suffer from some sort of breakdown. Can you see here as well, look at these pins, like really weirdly oxidised at the top. Now that was in that socket, wasn't it, and the legs are super short. I'm just wondering if that wasn't making a good connection, you know. That's maybe a good PLA. It may just be that it wasn't a good connection in that socket. This is where you need, when you've got legs that short, you need turn pin sockets. I'd be amazed if that was making a proper connection in there. So you know what, the PLA might be alright. Let's switch that off. We'll take this out and we'll clean up this. So I've still got the wrist strap on here. Technically, this could generate some static and you could kill it that way. But anyway, let's just clean the bottoms of the pins. I'm going to go right up the top as well, just because there is a bit of oxidisation on there. But that won't be causing the bad connection. They're kind of glossy. The C64C has a different PLA. I'll show you that board in a minute. I've covered one where there was a bad trace on one. But that's a sharp chip, and those never fail. They probably do, but I've never come across one with a bad PLA on the C64C. But these fail for fun. And this is a board I fixed previously, and you can see the PLA socketed there, but normally they're not. So yeah, these sharp PLAs on the C64C short boards. And it's interesting, I always found that interesting. They call this the short board, and the other one the long board. So the one we fixed in this video is a long board. Now it's not actually any longer. You know, length is longer than height, isn't it? If you know what I mean. When you think of width and height, the whole long board, short board thing doesn't make any sense at all, because I would say that this is a long board. It is longer than it is high. Yeah, does that make sense? Well, actually, the long board, the one you see me fix with the RAM and the PLA, that's a long board, and it's the same length as this board. It's just comes down further. It's actually, there should be, in my mind, a wide board and a short board. That's what it should be called. But anyway, yeah, those are hard as nails. They seldom fail. But this one does have the RAM inside, so maybe they fail more frequently than I'm thinking. The earlier one of these PLAs has got a separate RAM chip here for the colour RAM. This one's it's merged inside. So let's try that in there again. It might be advantageous to bend the pins outwards because I'm not sure that's in there. Perhaps it is. Let's try it. No, that's not working. So, yeah, maybe it is faulty. I think just for good measure, we'll take it out with the this extractor again. We can grip the thing, there we go. Because the distance on those legs, what I will tend to do with something like this is just bend, I want to bend outwards really actually. Let's just bend one side just slightly outwards, because then you'll get a bit of a spring sort of action as the other side pulls towards it, if that makes sense. That's a bit better, let's try that. Yeah, just a black screen, so that red dot perhaps indicates that PLA is faulty. Let's try it one more time for good measure, but I think we've worked out that it's definitely the PLA as well as the RAM. Yep, not doing anything. So I guess now we know that with 100% certainty, we may as well commit to putting the replacement straight in there. It'll make a nice tight firm fit. I think this is the one I bought, so let's just take that socket off the bottom, because if you leave that socket in there, obviously it's going to stand really high up in the case. It may not even fit with the lid on with that number of sockets. I just do this sort of thing for testing. Once you know that this is always going to live in here, and this probably will never die, these chips will probably outlive the rest of the system, if I'm honest. The final thing to do is clean all this fluff and dust off this board, and then just inspect anything. Yeah, nice tight fit now there, look. So other things you might want to do while you're here, obviously, is recap it. I've recapped some of these in the past, I've shown that. I wouldn't do it on every single one, because the caps, I've took them off as I've recapped a number of these, and they're always alright, actually. But it is a good idea to certainly replace those main three there. I'd perhaps do that if you plan on using one of these for any kind of extended period of time. The other thing is the lid that comes off here, so I'll show you, hang on. I took this off, prized this off, just have a look underneath. You can see it's got a copper thing there that acts as a heatsink for that, and the whole thing acts as a heatsink. But the crazy thing is, whilst it acts as a heatsink, it keeps the heat in as well to a degree, so I would remove it. You could include it when you ship it. I might just do that if someone wants it. Chip creep, and these chips here can creep out the sockets, the Vic can do, and you get typically with these sometimes a single wipe socket, so you get chip creep. Certainly not this revision, but I'll show you the other revision perhaps in another video. They can slip out over time, and even though you push it back in, it's really loose and it just keeps popping out and bad connections. So there's advantages to replacing that socket whilst you're there, but we'll clean all that heatsink compound off. I'll stick a separate heatsink on that. I'll probably fit a nano swin SID here. Now often I've sold these with the original SIDs, but you know what, I don't have any spares now, so I think I'd like to keep that. It's an R4AR, don't have one, so I think I'd like to add that to my collection actually as a spare. So we'll, you know, I feel a bit bad about it, but yeah, we'll backfill it with a nano swin SID or an arm SID perhaps. Other than that, it's just like a clean up of the board here. The contacts need cleaning up there. You can see they're particularly dirty back here, and got lots of dust and fluff all over this board. So testing here with a 1541 Ultimate 2. It's a cartridge, but it's got a 1541 provided by FPGA effectively, I think. So we've got the serial cable in there. It's going into the tape port, and I'm actually using it in tape loading mode at the moment. So you can point a .tap file at it, you know, a tape image, and it's just like using a data set. So I'm testing the tape port. We obviously tested the cartridge port and stuff as well at the same time and stuff, and that seems to be working. But I'll test a number of different games via disc and tape this way, and cartridges. I want to turn it up a bit. Yeah, that sounds okay. My cat's going nuts at the moment. That's not the SID. There we go, that loaded okay. So Grisor is the rename of Contra. I'm not sure, they must have had some sort of licensing issue. I need to swap the joystick port over, I think, unless we have a joystick port problem. Let's try the other port, there we go. Yeah, so it's quite good this. I'm not sure how good it is on the C64 compared to other systems. Yeah, shooting down diagonal's pretty hard. How'd you go down? I bet there's a key. I bet you gotta press space or something. Or maybe not. Oh, that was a quick game, wasn't it? Let's try again. Oh, there was, it did say there, fire and crouch does something. I can't work that out. I think you should be able to get down to lower levels, but maybe not. How do you jump? You can't jump either. Oh. There must be a key. Let's just read what it says on the title screen. Up to select. Oh, 1 player, 2 player. Fire to start. Yeah, so I don't know. It's a bit difficult without being able to jump, isn't it? One button is not easy. Oh, you can jump. Space, yeah, the space bar just needs a clean. There's one thing that always got me about joystick supported games like this is trying to use a key on the keyboard at the same time as the joystick. Near impossible. Uh-oh. Oh. Puts you right back at the beginning, doesn't it? Yeah, of course, you've got to get to the checkpoints, haven't you? So let's have a bit of a clean around this board now. There are some mucky marks here, look, some dust and fluff. So another point of interest, the PLA socket here has been fitted at a later point. It wouldn't have shipped with this soldered, I don't think. The socket soldered on. You can tell it looks like a third-party repair has been carried out there in the past. So it's probably had a faulty PLA more than once in its life, which wouldn't surprise me. We saw these with bad PLAs quite a bit actually. It's not just like a recent thing where they start to die. And the final thing I think here, I mean it might have some more spot cleaning from the top side when it's in the case, because there's still a little bit of dust. There's a bit of dust on that transistor there, isn't there? That's for the tape, by the way. Yeah, we'll use an eraser on here. You can see the difference straight away there. Well, it's like new. And obviously we'll do the underside as well. Anyway, you've seen it all before. Now, if you don't have a dead test cart, but you've got something like the Kung Fu Flash or a 1541 Ultimate of some kind, or any other kind of flashable ROM cart, you can just use that. You can put the dead test ROM image on there and it will work. It was thanks to, I think it was Simon, if not, I'll correct his name up there. Yeah, commented on a previous video saying he uses his for the dead test, actually. That's a really good way of doing it. Because something like this, it'll cost you about, I don't know, 40 or 50 quid. And yeah, you can use it for multiple things then. The only thing that's lacking on these, you saw this repair recently, is the disk drive side of things. Yeah, you can load PRGs off a D64 image, that's a disk drive image. you know, you've put on your SD card there, and lots of games work that way. But ones where you've got a disc that's got multiple PRGs on it, you tend to find they don't work with someone like that. So that's where someone like a 1541 Ultimate is a bit better, or perhaps the SD to AEC might be a bit better in that respect as well. But that's just my experience of using these. The disk drive side of things, yeah, it's okay, but it's not great. Yeah, post your comments down below about that. Maybe you've had a better experience than me. I am on the latest version of the firmware there. Look, you can tap it. I'm not sure if the nut's still there. So let's just carefully get the strap on, lift this board out, disconnect those things, just lift the board out, and let's just have a look on the underside of that. It's probably easier if I just take the cartridge out as well, actually, while we're at it. It didn't come in this case, by the way. Another board did. Yeah, that'll explain it. There's no nut there. Why is there no nut there? What's happened to the nut? So, bear with me. I'm just going to go look through my nut collection and see if I've got a nut to fit that. Right, I've got a nut on there, but you can see how low profile that is, and it's obviously square instead of hexagonal. But it needs to be like that because there's literally none of the screw protruding through there, so that's tightened up, and yeah, that screw is now nice and firm, can't move it. You could of course put some thermal compound behind those, because you know what, I'm not sure either of them have got that, but they don't get especially hot. We'll just give that one a bit of a, no, it's totally tight, that. I'm just going to just wipe that off with a bit of IPA, and we'll stick a label on it to say it's fixed. And as I say, I'll probably backfill this SID position because I want the 6581R for AR. So if you had one of these where your MT RAM was bad, you might want to swap all those MT RAM chips, certainly for long-term reliability. So just a bit of file testing here. You can hear the Nostalgia remake of Ghosts and Goblins there. Thought I'd just show you this actually. This came with the Kung Fu flash cart. I forgot to show it. It's a collectible, you know, memorial coin here. The Commodore symbol on it. And on the back it says Commodore 64, and it's got the nice rainbow stripes there, 1982 to 1994, with the ready and the little cursor. That's quite cool. Yeah, it came from this company here, Facebook 7 Sided Mint. Oh, yeah, it's not a complete system, this one. You can see it's in a C64C case there, but I don't have a keyboard for this, so yeah, whether this board stays in here, I'm not sure. And obviously it's missing the bracket here. I just happen to have one of these spare from a board that I decommissioned a long while back. Now I need the two screws to support that in, but yeah, I think we can get that in. And it only had like literally 2 or 3 screws holding it, and I've got a full set of replacement screws here. There we go, that plate is now perfectly aligned. That's it. So the board is totally secured in. I've got Plan C's PLA on there as well, so thank you very much to that. I think his name's Brad. Cheers for that, Brad. Got 3 copper heat sinks on the VIC chip there. That gets hotter than anything else on the board. There is advantage in heat seeking the CPU, but you know what, it doesn't get that hot. I played this for a couple of hours yesterday, and yeah, that wasn't really any hotter than anything else really, but this was like 2 or 3 times hotter. Keyboard connector pins were straightened there as well, because those were a little bit crooked. Get the keyboard back on. That's it. And the power LED, you can get this either way, is 3 pins, as long as you get all 3 pins through the holes. You can't get that wrong. And the clips on the back of this bread bin case are all perfect, actually. That's surprising. They've all lasted. So you sort of hinge it down like that. Ow, trapped my finger. You can see someone's been messing around with this in the past. It really annoys me. You know, they tried to prise it off and it's warped and all the rest of it. So I'm going to try a technique I use for dealing with plastic edges. I might have to replace this ultimately, but before we do that, before we commit to removing it and replacing it with something third party, let's just try my technique here. And it's a rubber handled screwdriver. Oh, and it's a case of rolling it like that, and you can see straight away I've managed to get some of the ripple out there, and even the plastic end, you could use that. You can sort of rotate it. Yeah, it's still stuck up a bit, so I may need to use an incredible amount of pressure, which risks breaking the shell. But yeah, you know what, that's straightening out. that is straightening out a little bit. It's just on the top there a little bit now. You know what, that's not half bad actually. There is still a couple of creases there. If you look at it from the front, it's an awful lot better. You know what, it doesn't look it at the moment because that's sticking up, but it's 1,000 times better. I've almost got this right. I'm going to use the EV blog ruler to get here because you know what, I feel a lump there, a lump here. And if we get this into that gap, yeah, it's going to recess and it's going to fall into the gap. And then if I do this, it's flat. Does that make sense? Yeah, it's getting there. I think the easy way to straighten this totally is to get it off, and you can see just wobbling like that. Look, it's only held in the middle by a bit of sticky tape or something. So we can get it off like that. Because straightening it off here will be far easier than trying to straighten it in that little gap. So yeah, we can replace that. But now it's like this, you see. It's easier to put this on a flat surface and roll over it almost, you know. I mean, you can literally, you can see I can bend it like that now, so I could, you know, put a little bit of pressure like that, and already it's starting to straighten up. But it's these little creases on the edges we need to deal with. Well, now I've got it off here, I can put something flat like this ruler there, and on a very flat surface like, I don't know, a kitchen table or something, then roll this over there, and it should straighten it out somewhat further. So I cleaned out the gap there and have straightened this out somewhat. So from the front, actually, it looks pretty good. If you look at it in light, you can see ripples and creases and things, but it's an awful lot better than it was. So I figure once I've used an eraser on the silver bits, that'll come up looking a bit shinier. You won't be able to tell, I don't think. So I mean, when I sell this, I'll put on the advert, probably needs a new badge, because somebody has messed with it in the past. I've made it better. But anyway, so we've got 2 layers of double-sided tape here. I just need to peel back this top layer now. There we go. So we'll just flatten that corner down a bit. Right, there we go. And let's try and stick this in now. There is a bit of a sort of gap you've got to leave, or you have a sort of gap, a bigger gap on one side than you do on the other. That's it. It's pretty central. And we'll just press it down. You know what, that looks 1,000 times better. Actually, that does look 1,000 times better. Let's just put this ruler here like that and just press into the edge. Just because that edge is raised a little bit compared to the other one. That'll do. Yeah, so in the light, actually, it's a lot better. Hopefully you'll agree. Of course, in the dark, it looks even better. Right, anyway, let's just bring the paper towel here, just because I'm going to use the eraser. So, I'm not sure if I've shown this technique before. This usually works on these silver Commodore badges. You just have a bit of a rub, just on the silver bit, not on the ink, because you could actually wear the ink a little bit. But they've got like a silver fascia, if you like. And just by doing that, you actually remove any dirt and grease and oils and things that have got on top of the silver part. I'm not sure it is silver, I don't know what it is, but it's, you know, it looks, it's metal. It's probably the aluminium of the actual badge, you know. One other thing I did there, and I didn't show it, to get it totally flat there, is on the edges, crimp it with these. They're super flat. Yeah, so as long as you don't crimp too hard, you won't damage the metal, and it is aluminium. I'll show you here, this was like the label, and it was like, I put it on this ruler flat, and then went crimp, 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 in a few different places, and inspected, and I could see it was just flattening it. It wasn't leaving any marks from this, but if you were too rough with a tool like this, or it had a rough surface, you would start to remove the paint covering. But yeah, I think you'll agree, that looks so much better. And if I didn't already mention, I've got 3 screws here that came from a bread bin that was decommissioned. I think it was that one ages ago that had a melted case. I don't know if you saw that. That would over tighten these whatever you do. And there we go, you can see the serial number on the underside. It's pretty clean on the back. There are some scratches up here though, look. But that doesn't come out bad, and you know what, the badge from the front there doesn't look too bad actually. So a huge thanks to ElectronAsh for donating this to the channel. There's going to be some more C64 videos coming up, and a huge thanks also to Plan C for sending that PLA replacement there. That's been really useful, and that's exactly the one that's gone into this actually. So I do hope you found the video interesting. If you would like to support the channel, please see the Ko-fi and Patreon links down below. Thanks for watching, thanks for subscribing, thanks for commenting, and I'll catch you in the next video.